going to talk about some quite introductory stuff, so lots of stuff about ideas, what scraping is, why you might use it as a journalist, what is actually scrapable, so the kind of opportunities for scraping that you might come across, and possibly when things aren't scrapable. Quite often people overestimate what is possible to kind of automate and gather in terms of information, or underestimate the effort required when sometimes it is scrapable. And I'm going to touch on some tools. Depending on how quickly we get through it, hopefully we'll get to do some practical stuff as well. So firstly, I should kind of explain what scraping is for anyone who doesn't know. It's actually really quite hard to boil it down because there are so many different examples of scraping. But fundamentally, it's kind of writing bots or getting bots, robots, to do work for you. So anything repetitive, and specifically the repetitive gathering of data, that is basically scraping. So if you're having to go through dozens of pages and getting information from each one of those pages, that is scraping. Likewise, if you wanted to get hundreds of spreadsheets, go through all of those and combine that. Or if you wanted to go through thousands of PDFs and get a little piece of information from each one, then that would be scraping. Or sometimes it's just one web page or one document that changes every week or every month, and you want to automate the checking of that information. So anything that involves repetitive work, you should really be looking for a computer to do it for you. Some people have a real concern about this kind of, well, if I let a computer, if it's out of my control, direct control, then there is a possibility for mistakes to be made, which is very true, but it's actually more likely that you're going to make mistakes if you're doing that with humans. So a computer will make mistakes, but it will make mistakes in a predictable fashion that you can test. Humans will make mistakes that are actually quite often harder to test. So if you're transcribing numbers, how do you know which one has been transcribed wrong? So in many ways, automation is a better way to deal with repetitive work. And also it makes possible a lot of things that just would not be possible otherwise. Things that would take months or years to do can now just take a matter of hours. This is an investigation by Channel 4 News a couple of years ago, and this was looking at Universal Job Match, which was is a government website where if you are claiming unemployment benefit, job seekers allowance, you are required to use this site to look for jobs. But basically, a significant proportion, probably more than half at the time, were completely fake, and that was partly because of the way that the system was designed to essentially pay commission to people who place jobs. This involved cycling through lots and lots, hundreds and hundreds of pages, gathering the data and looking for odd patterns, looking for duplication, looking for timing, things like that. And the government climbed out, it kind of said, they apologised that they weren't really checking the accuracy of these jobs. And immediately after, about a third of jobs disappeared from the site. So that gives you an indication of the scale of the problem here. Now, I looked at that data about 3 months later to see what had happened after the government said it had sorted it out. And what happened was the job numbers started creeping back up and some very odd behaviour took place. For example, one recruitment agency over 3 months placed 98% of its vacancies on one Sunday. Now, it seems a bit odd to me that one recruitment agency would have 98% of its jobs come in on one day, on a weekend, on the quietest day of the week. That stinks of some sort of automation. This is a much softer example, and I use this because it's a really good example of spotting an opportunity for scraping, which isn't your traditional kind of statistics or hard news, but just seeing that as soon as you start to put information online, as soon as you digitise it, it has a structure that can be interrogated. You can ask all sorts of interesting questions. So what happened here was some person noticed that musicnotes.com has over 260,000 sheet music arrangements. So that is structured data. We can go through those 260,000 sheets of music and say what is the highest note, what is the lowest note. And let's look at that by artist. So this mirror story kind of started with your David Bowies, your Freddie Mercurys, and counted down to the singer with the widest vocal range, which was, bizarrely, Tom Smith of the Editors. For those of you who don't know, it's kind of a bit like Joy Division or Interpol. So not exactly a singer or a band that you would associate with enormous vocal range, but this was the range of notes, of vocal notes in their songs. So things like that can give you some really quirky, really interesting stories. You're probably aware of Buzzfeed's tennis racket story, another one based on scraping. In this case, it was looking at odds around tennis matches and results. So what they specifically looked for was matches where the odds changed significantly. So they changed across a particular range, which is an indication of large amounts of bets being placed on a particular result. And then they also looked for the results of those matches and results which were unexpected. And they found some strong evidence of match fixing, and it led to all sorts of investigations in the sport. And sport's a great area for scraping because you've got lots of data and you've got the gambling aspect as well. Another big recent story, the privatised investigation into offshore ownership of properties in the UK, likewise involved scraping. This is a story I worked on with Tom Warren at the Bureau of Investigative Journalism. They were looking at payday loans at the time. The hypothesis here was that payday loan shops were setting up shop in areas, deprived areas, where people probably couldn't afford to pay back the loans. They certainly couldn't afford to get credits elsewhere and were having to pay high interest rates. So to test that hypothesis, we needed to get the location of payday loan shops and combine that with information on deprivation. So that's what we did by cycling through hundreds of pages on the payday loan shop websites, grabbing the addresses, and then mapping that and comparing it. And then there's this story, which I'll talk in a bit more detail about because there's a number of scraping techniques involved in this, which I think are useful for demonstrating how different ways that scraping can be useful. So very timely, 4 years ago, the last Olympics, the London Olympics, there was as there is in every Olympics, a torch relay. So the Olympic torch is taken from its birthplace in Greece to wherever the Olympics is taking place that year. Now, because of the protests in the previous Olympics in China, most of that relay took place in the UK. So it was basically carried from Athens to somewhere in the southwest by David Beckham, and then it was carried across Britain. Now, when that was announced, it was various promises were made around what this torch relay would represent, what it would be about. So it was about celebrating local heroes, celebrating youth, celebrating people who have contributed to the community. A claim was made about the proportion of people, I think it was 95% of places would be made available to the public. So there were a key number of claims around this. And I happened to come across the data, well, not the data, but I came across the official website for the torch relay and noticed that they had a page for every torch relay carrier. And when I saw these pages, I thought, first of all, this is structured data. I've got a page for each person. It's got the name of the person, where they're carrying the torch, where they're from originally, and their nomination story, and their age, among other things. So straight away, I can start to test things like, okay, who's the oldest torchbearer? Who's the youngest? Where do most of them come from? These sorts of things. And I can start to test these claims. And what happened very quickly was I started to see some suspicious patterns in this data. And these were some of the stories that came out of it. And there's an ebook, a free ebook, although if you pay any money for it, because you can choose to pay however much you like, money from that goes to a charity which has a connection with the story. So what I did was I wrote a script to go through all these pages and grab all these, grab the name, the age, all these sorts of pieces of information. And then I had a spreadsheet. And that spreadsheet had about 6,000 rows in it. So there were about 1,500 stories missing, actually, 1,500 names missing, which itself was an issue, because if you're going to claim to be giving 95% of places to the public and 8,000 inspirational stories was the claim, then if you're only publishing 6,000 of those stories, what's happening to the rest? So again, if you've been at the SQL sessions earlier, this was an example of a SQL query that I ran on the data. And what I was looking for is anywhere where the nomination story mentioned one of the sponsors, so Coca-Cola, BT, McDonald's, Panasonic, and so on. And when I did this with Adidas, I got about 23 results. Some of them had mentioned kind of Adidas events, things like that, but 7 of them had exactly the same nomination story, which was very odd, because you're supposed to be nominated by someone else. And they were written in the first person as well. And they all mentioned about the business of sport. And there's this lovely line, "I hope I have also contributed to the development of sport in our country," which is very nice. I hope you have as well, because otherwise, why are you carrying a torch? And part of this process is narrowing the focus of your inquiry, reducing the amount of fishing, essentially, that you've got to do to find your story. So from 6,000 stories to 23 to 7, very quickly I'm able to start focusing my efforts. Who's Christos Angelides? Who's Tom Foley? If you Googled those names, you'd find that there's an executive of Next called Christos Angelides. He's in the most powerful people in retail list, and supposed to be on a triple-figure kind of salary or 6-figure salary. But I don't know if it's the same Christos Angelides. That's the next step. Tom Foley happens to be the name of an executive of another clothes retailer. Both of those clothes retailers have commercial relationships with Adidas. The day after they ran, I got in touch with a local journalist and said, "Have you got any pictures? Do you know if there's any pictures of this leg of the relay?" And lo and behold, there was a picture of these 2 people exchanging a torch kiss, which is where you hand over the torch to the other person. You're not allowed to choose your place on the torch relay route, so it's an 8,000 to 1 shot that these 2 people, who now I can visually verify are the executives in question, because I've got 2 photos to match up. And coincidentally, a local hurdler, a 17-year-old boy, had been told he was not going to be carrying the torch after all, because he had failed security checks. That was just one of the stories to come out of it, and actually there was a big backlash that was running in the Daily Mail, ran that story, as well as the local paper, and the young boy got to carry the torch again. But lots of quite stinky stuff just through that process. The other thing that happened was I didn't just scrape it once, but I kept scraping it as the torch relay was going on, because what I found was that names would appear and then disappear as people tried to cover their tracks. And actually, in trying to cover their tracks, they drew attention to themselves. So I would find names that I wasn't really looking for before. And when you started to search for those names, you found, oh, it happens to be a Samsung executive. That's a Samsung executive as well. And then you get a follow-up story, which is this guy that we wrote about last week. Now his story's been taken off a website. So we've not only got the story about the guy who's carrying a torch because he won a sales competition at Samsung and sold the most mobile phones in Norway, another inspirational story. We've not only got the story about that, which ran earlier, but now we can run another story saying, look, they're even trying to cover up the tracks as well. And then, of course, you can quantify things as well. So if we've got 7,000 stories, which is what we ended up in the end, we can start to say, okay, you promised that half of these torchbearers would be aged 12 to 24. This was a celebration of youth. Because I've got the age of every torchbearer, I can actually say how many were aged under 12 to 24. And it was far from half. And even if all the 1,000 that we don't have details on, even if all of those were 12 to 24, you still would be well short. You would only be 40% of torchbearers. So why did you not meet the promise that you made? So there's a few things there. There's the quantifying, there's the narrowing of focus, and there's the looking for cover-ups and information being taken off or added on. Some other stories. This was for the Scotsman. On the kind of an audit body in Scotland, they publish spreadsheets for each local authority. So I wrote a scraper that pulled all those together, about 30 different spreadsheets, into one so that journalists could query it for various things like, you know, how much do sickies cost, what's the frequency of visits to old people. So you can start to do a simple pivot table with that. And that was just a goldmine of stories where you could kind of ask it any question you like. You've got simple stuff like this. So you might just be scraping tenders or contract awards for kind of a regular update. Doesn't have to be investigative. You can do regular updates. The BBC's A&E tracker was essentially a scraper that went and checked websites, spreadsheets called SitReps that the health service publishes about how many people have been seen within 4 hours, how many ambulances are queuing, that sort of thing, rate of infection. And so because that was contemporary data, it was being published kind of every week, they could have this regular tracker. So at this point it's been running for 16 weeks, and you could kind of find out how's your hospital doing. And it's particularly useful with live data or very up-to-date data like that. Also with the BBC, this was a story I worked on earlier this year. Again, this is kind of testing a claim of as a gap in knowledge. We know that there have been cuts to libraries, but what has been the scale of that? How many of them are being now run by volunteers? What's the staffing cost cuts? So part of that story was sending FOI requests to all the local authorities. The other part was scraping about 350 reports on libraries which covered a 3-year period to find out things like how many books were being borrowed, how many outlets there were. To some extent, there's 2 parts to this. One is about second sourcing, and so you've got another source compared to your FOI. And the other is that sometimes when you do an FOI request, they will decline it because this information is already published. But if that information is published across 100 web pages or 300 documents, then that's not much help to you in terms of being able to write a story about it. And to some extent, that's why I started getting into scraping, was I could see that, first of all, people were getting trickier and trickier in terms of avoiding responding to FOI requests. It's also quicker than FOI. But also, increasingly as information is published, and not always in the easiest format, we need to be able to get that information into a coherent form that we can ask questions of. Ed Lafer used scraping to look at who are the people who asked the most questions at Prime Minister's Questions time. We looked at the average cost of property around the UK to scrutinise the Help to Buy scheme. This got 1 million views in the first 24 hours. Really touched a nerve. The big problem was some of that data came from Zoopla, and when I looked at the terms and conditions, we're not allowed to scrape Zoopla. So what we had to do was get on the phone to Zoopla and say, can we have your data, please? So if you are considering scraping, it is worth checking the terms and conditions of websites. You can make your own judgment in terms of the risk. You can talk to your lawyers about that. But that's a legal aspect worth considering. Do the terms and conditions prohibit scraping? Yeah.
Is there any examples where they've taken action against someone?
Not journalistically, no. There's an example in Germany of I think it's an aeroplane company sued a website which was basically scraping their data in order to sell flights. So they're basically a direct competitor. And that's the most likely scenario. What these are largely designed for is to stop someone else just copying all your data and then competing with you using the same data. It would be, I think on a risk basis, it would be a bad move for an organisation to sue a journalist for something which is not kind of a commercial competitor or anything like that, and there's a clear public interest in it. The other thing to be aware of with scraping, and it's unlikely to be an issue unless you are hard coding a scraper and writing it yourself, but if you're making excessive demands, if your scraper is making excessive demands on a site, to the extent that it impairs the performance of that site, then you might be sued for essentially damage, criminal damage. So if you are writing scrapers, then you would have a delay within that scraper, so it's not kind of hammering it thousands of times a second or something like that. You would make the scraper gentle enough that it was not impairing the performance of the site. Another story involving scraping. This was again, the Bureau had done some FOIs, but they needed some data from police reports. So in this case, I wrote a scraper which went through 82 police force reports, 41 forces for 2 years, to grab just one figure from each report on the number of rapes that had been reported. And this was to establish the hypothesis that, or to test the hypothesis that rapes were not being treated particularly seriously or seriously enough by police forces. Softer stories, again, you know, how are you as unpopular on Twitter as you really think? Actually, all those people with loads of followers, it's misleading. Most people have fewer than 50. And John Byrne Murdoch, one of my former students, did this interactive before the last World Cup by scraping performance data for all the players that were in each squad at the World Cup. So you could see that England, obviously we expect England to do really well at the World Cup because individually the players have got the best shot accuracy in that group and they've scored more goals. So it can be helpful but not always an accurate predictor. And then scientific journalism as well. So this was looking at how kind of incestuous scientific publishing was. Hotel reviews and what's most mentioned in hotel reviews. Bathrooms, it turns out. People are really bothered about bathrooms. And review sites like TrustYou and TripAdvisor, not TrustYou, are again really interesting sources of data, anything that's got lots of information. Or Instagram, what foods mention the most on Instagram? What hashtag appears the most? Turns out bacon is very cool. So I just wanted to show you lots and lots of examples to kind of get you thinking in different ways about what might be possible to scrape. It doesn't have to be hard news, it doesn't have to be kind of numbers, it can be words, it can be sport, it can be music. It can be dates, things like that. What you're looking for is a pattern. And that's what makes a website suitable for scraping. You're looking for a pattern. So here's a really simple example. This is in Ireland, the Irish Nurses and Midwives Organisation publishes a table of a number of people waiting on trolleys at each hospital. And this is updated kind of every day. So if as a journalist you're having to check this every day, that sounds like a bit of repetition that you can design out of your workflow really. Why not just scrape this into a spreadsheet or run a scraper which grabs it every day so you've then got a picture over time? And the structure here is very obvious. It's a table. If you see a table like that, it's scrapable. And if it's a number of pages with the same kind of table on each, then likewise it's scrapable. Similar example, work for an MP if you're interested in who's advertising unpaid jobs. Then this has a very obvious structure. We've got, and it's not a table, but what we've got is again a pattern. We've got a number followed by a dash, followed by the job title, followed by a comma for the employer, location colon, salary colon, posted on, date, comma, closes on, date, a link to the description, a logo. These are, and that pattern is repeated throughout and on every subsequent page. So that sort of pattern is scrapable. What's really important to recognise on this is if you've got a number of different websites with different structures, that is not scrapable because they have different structures. So if you wanted to scrape some information from every local authority in the UK or every police force, they will have different ways of publishing that information. It's not always going to be in the same structure. So it's almost never the case that you could write a scraper that went through every local authority and grabbed a piece of information. You could write a scraper which went through one local authority website and grabbed pages and pages of information, but you'd have to write a different scraper for a different local authority. Another pattern to look for is the URLs. If the URL has a pattern, then that is a big help as well. In the payday loans example earlier, Tom was kind of looking at the map on the particular company website and trying to get to the data underneath that. But actually, when you looked at the URL for an individual store, it was literally paydayloancompany.com/stores/125. And then another one might be 342. So all we needed to do was generate a bunch of URLs from number 1 to number 500 and go through all of those and grab the information. And if there was one at 500, then we'd carry on to 1,000. And it turned out after about, I think it was about 650, then it stopped. So they had 650 stores, they were all numbered consecutively, and they each had that kind of patterned URL. But there are, broadly speaking, two types of challenges that you're going to face. The first is document challenges, and the second is the hosting challenges, the URL. So I mentioned the table on that Irish Midwives website. So if it's a table on a HTML page, that's really easy, and that's one of the examples I'm going to tackle in the next session. Alternatively, it might be not a table, but still within tags, like the work for an MP example. And you can say anything within these tags, or within these words even, grab that. There might be data in a JSON file, or XML format, or text format. It might be a spreadsheet, it might be a PDF. Worst case scenario, it's a PDF which is scanned and needs optical character recognition. But all of these are scrapable. The further you get down, the harder it gets. Anything other than these two, you're probably going to need programming to do. But most cases do fit into those first two. In this last case, you're not only going to need to scrape it, but you're probably going to have to run each PDF through an optical character recognition tool. The URL challenges are, you might have one page which changes every day or every week. You might have a number of pages which are all linked to each other through next, kind of page 1, page 2, page 3. Or you might have a bunch of pages that are linked from a single page. So this page links to Manchester, Birmingham, London, Liverpool, and so on. Or you've got a number of pages which have that pattern that I mentioned earlier. Sometimes the pattern is search results. So you will do a search and the actual result of the search will be in the URL itself. It'll be something like question mark, location equals London, location equals Birmingham, and so on. Again, getting further down, it gets harder and harder. Sometimes you'll do a search and the URL does not change. And that's because your search is stored in a cookie, not in the URL. If you want to scrape that, then you'll need somewhere to store that cookie and grab the details as the searches are automated. And the worst case scenario is you need some sort of login to get hold of it. Now, if you're getting onto this point, again, there's legal issues, because if it's password protected or something like that, then you don't have that defense of saying, well, this is public information. So here's one example. Let's say we were interested in graduate jobs and low pay for graduate jobs. One place we might find that information is jobs being advertised on a website like Reed. And what are we looking for? Well, we're looking for structure. We're looking for this next pattern, a lot of linked pages. That's really useful. The jobs themselves follow a particular pattern. And this happens both at the code level in terms of the tags and the text level in terms of there might be certain characters, certain words that always precede or come after the information that you want. And it might be a combination of the two. Sometimes it's a pattern in terms of, for example, if you wanted to grab the date, and the date is always 1 or 2 digits, followed by a space, followed by a word that begins with a capital, followed by a space, followed by 4 digits, which is a year. And you can describe that pattern to your scraper. One really useful tool for looking at these patterns is the inspector or developer tools in Chrome. So if you right-click on your page, you right-click on a particular thing that you want to grab, and you select Inspect, and then you right-click on that element and go to Copy. This is in the inspector. You can copy things like XPath, which is a way of describing a path to some data. You can copy the selector, which is sometimes used in scrapers. You can copy the outer HTML, which is the pattern of text which comes before and after what you want. Another useful technique is if you've got a patterned URL that has some sort of ID code in it. Each of these pages, there wasn't one single place that linked to all of these pages. So you had to generate the URLs, but the URLs weren't consecutive, they were all based on this ID code. So what you need is a list of ID codes to generate that URL. So you search for one of those ID codes, and the name of the school, and file type XLS. So you're looking for spreadsheets with ID codes in them and the names of the establishments. And then you can generate URLs by just adding that number to the URL and copying them down. Another thing about URLs is often they have elements which are not needed. So going back to Reed, if you click on one of the jobs on that search result, you'll see this is the key thing of the pattern: job/graduate page size equals 100, okay, and an ID code for that job. But then you've got all this stuff which is the actual job title itself, and obviously that's going to be different each time. But you should always copy the URL and play around with it and see what happens when you change bits of it. So that bit is actually just for search engine optimization, the job title and the URL. You can change that to anything, literally, and it will still work. And that's quite common in URLs now. You will have some code which is meaningful, but some other words which can just be replaced with anything. If you put a file called robots.txt in the root directory, so basically at the bottom of your website, then that is interpreted by search engines and other web crawlers as a series of instructions as to what you can or cannot index from the site. And it just says things like, don't go to that folder, don't go to that folder, and so on. And most of them are pretty innocuous, uninteresting parts. So that's one way that you can kind of instruct search engines not to scrape your site, which is essentially what scrape engines do every day. Is they go around millions, billions of pages and scrape them and find out what text is on them, what's linking to it, and store all that information in a big database and use that to produce search results. The other thing about scraping is you should treat data as just as you would treat any other source, whether that data is scraped or not. With scraped data in particular, I would recommend building in too good to be true checks. So in other words, if you've got numbers from your results which are excessively high or excessively low, you want to be testing for that. And like any source, you should seek second sources. Is there some other source which can help me be more confident about this information? And people often worry about having lots of data and having to verify all of it. The key thing is verifying the stuff that you're writing about. So if you see that this particular organisation, like with the libraries, this library has sacked more people than anywhere else, then obviously you would approach them and say, can I check, can I confirm this? You know, what do you say about this? If they say it's wrong, they might still be lying. So you've got to retain scepticism about them just as much as you would be sceptical about the data itself. But it does give you that strong position to be able to go to someone and say, I have some evidence. What do you say about it? What, you know, okay, if it's wrong, why is it wrong? Prove to me. Have you got flawed data? Which has happened in the past, and often these stories, there was a story in, I can't remember what part of it might have been Texas actually. There was a story about hundreds of convicted criminals who in the records were listed as having committed different offences, including child abuse offences. And this is a public record. So if you went to check your neighbour, what, you know, are they in the criminal records? Oh, they're a child abuser. No, they weren't. The data was wrong. And I think those are some of the most important stories you can tell, because data has an incredibly powerful role in policy and all sorts of other areas. The other thing to look for is this is a great flow chart from Storybench. One of the points there is, do they have an API? Now, an API is a way of querying data rather than scraping it as such. So the Food Standards Agency example there, that's actually an API. That list of files, that list of links is an API. They update it and you can query it and people build apps based on that API. The police have an API at data.police.uk where you can query data about crimes at a particular location, crimes of a particular type. It's about 2 months behind where we are now, 2 or 3 months. But if they have an API, that's a much better way of grabbing that data. It does involve programming, but it's a better way of grabbing that data than scraping it. So if you're filing an FOI request, you're placing a bigger burden than if you scrape it and it's public anyway. You've got to wait at least probably 4 weeks longer to get it, and they might still turn around and say, well, it's public anyway, which they can rightly do. If there's privacy concerns, one thing that isn't here that's worth pointing out is if it kind of identifies individuals, think about how you present this information. You might present it in aggregate form rather than individual points for each person. There was an example of gun permits, a story about gun permits in the US where they published a map, an organisation published a map of everyone who has a gun permit in New York, and you could identify individuals and so on. There are a lot of concerns about that for various reasons, but it wasn't key to the story. The story was about general patterns of gun ownership, so there's no need to show every individual. And that's got a legal implication as well. There are database rights and database copyrights which apply to any data set. Copyright applies if some creativity has been involved in compiling it. So the fixtures list, for example, is covered by copyright because some guy has to manually make sure that Celtic and Rangers aren't playing at home on the same weekend. And you can't republish the fixtures, the fixture list, without permission from the relevant, you know, the Premier League, the Football League, whatever. Train timetables involve no creativity, but they have had, if they've had kind of financial investment in being compiled, then they're protected by database rights. But the key thing with both of those is that applies if you republish it in full. Now, I can say that Arsenal are playing Everton this weekend. I'm not breaking the copyright of the fixtures list. It's only if I republish the whole fixture list. So if you've got a data set which points you to a story, and the story is about one or a pattern or whatever about that data set, and you're not republishing the whole data set, then it's unlikely that you're breaking copyright or database rights. Or you can still write stories about individual points in it rather than the whole thing. I'm going to mention first of all a whole bunch of useful tools, and then I'll focus on a couple specifically. Broadly, you've got what I would call Wysiwyg tools. What you see is what you get. So tools where you click buttons, you don't have to write any programming, anything like that. Two of the best known are import.io and Outwit Hub. Import.io is web-based. Outwit Hub is a client that you download to your computer and run from your computer. Outwit Hub, there's a free version which will scrape up to 100 rows, so you can play with it. And if you want to scrape more than 100 rows or use some of the other features that it has that are not available in the free version, I think the pro version is about 40 or 50 pounds. Import.io likewise has kind of pro and free options. In Google Sheets, you can use what are called import functions, so a series of formulae for bringing data into Google Sheets, which essentially amounts to scraping, and that's one of the things I'm going to show today. And then you've got more advanced programming tools, so ScraperWiki and Morph.io are environments to write scrapers. They're not scraping tools as such, they're just coding environments, but what they do allow you to do is write scrapers without having to create the environment on your computer to do that, which is kind of another hurdle technically. You can just write scrapers from your computer, but it's just harder than using these tools. So I'm going to touch on some of these. I'm going to touch on another one called IFTTT as well. This is Outwit Hub. I probably won't go through this today, partly because you need the pro version to really appreciate it fully. This is import.io. In this case, I've just done a search on Reed for social worker jobs and copy the URL of the result. If you paste that into the box on import.io, it will start to look for the structure in that page. And this is that page as a scraped data set. So this is the page itself. Obviously, you've got lots of other things like menus, search boxes, might be advertising on it. But what import.io has done is look for some sort of pattern, some structure on there that looks like data. So it's picked out the title of each job, posted date, a link, location, and so on. And it's put that into what you would recognise as a spreadsheet format. So you could start to, if you downloaded this, you could start to look for, what location are most of the social worker jobs being advertised in. You might be interested in an employer that keeps having to re-advertise jobs. Is there some problem there? The wages, are they going down, or are they poorly paid? Are they minimum wage? And so on. One of the stories in the wake of the referendum was how much fewer vacancies were being posted as companies put a halt on recruitment in the wake of the referendum result. That's a classic kind of scraping story. Once you've got this preview, and I think you need to be logged in to do the next step, there's two options at the bottom here. One is download it as a spreadsheet, a CSV. The other is to save API, which sounds a bit, if you don't know what APIs are, might sound a bit confusing. And even if you do know what they are, it doesn't necessarily tell you that that is how you scrape more than one page. So if you click Save API, it'll be saved to your APIs. An API, by the way, is a way of querying data. It's a way for two applications to communicate with each other. But you can be one of those applications by asking it questions. Once you're in your API, the API that you've just saved, at the moment it's on single URL, but you can choose bulk extract. And when you select that, you'll get a box like this, and you can paste the URLs that you want to scrape. This is the URL of the second page of that search. So if you click next on that search, it goes to page number equals 2. You'll have to generate a bunch of those URLs and then paste it in order to scrape multiple pages. So in a spreadsheet, you would generate a bunch of numbers from 1 to whatever. Just type 1 and 2, then select both, and then hover over the bottom corner and drag that down, and it will copy down in sequence. So that's how to generate a bunch of numbers. And then to generate the URLs with the number at the end, you put equals, and then in quotation marks, the URL up to the point where the number normally appears. And then close the quotation marks, put an ampersand, and then the cell reference where your number is. And as you copy that down, you'll see it just puts 2 on it, 3 on it, and so on. This is how you would generate a series of URLs in a spreadsheet, and then you would copy those URLs into the box in import.io. I think you have to create an account on import.io before you can save it as an API, because it essentially saves it to your account as one of your scrapers. Let's explain what IFTTT is. As the name suggests, it's a tool for automating actions. So what you set up is a trigger, if this, and then an action, then that. So a trigger might be, if I post a tweet on Twitter, then post the same text on LinkedIn, for example. So it's quite commonly used if you're having to post the same content to multiple social media platforms as a way of just copying it across when you do that. But one of the most useful parts of IFTTT is that one of the channels that you can pick, these are called channels, they're basically services. One of them is Google Drive. And one of the actions that you can activate in Google Drive is to add a row to a spreadsheet. So that means that you can set up a recipe that says, if this person tweets, then add a row to this spreadsheet with their tweet in. Or if someone updates a Facebook page or an Instagram account, then add those details to a Google spreadsheet. If you are tracking an individual, for example, or you're monitoring what a politician is saying and anything that they might delete from social media later, you've got your own personal record of that. So, for example, I had a student at Birmingham City University who was looking at local politicians and what they were doing in the run-up to the last general election. And so in that run-up, he set up a scraper using IFTTT for each of the local MPs and candidates. And he then had a body of data after 4 weeks where he could analyse, for example, were politicians coordinating their tweets around a particular time. You had, I don't know if you remember, during one of the debates, lots of MPs suddenly tweeted, "Great point, George Osborne," or he's really fighting his corner, like these robots were suddenly kind of all coincidentally saying the same thing at the same time. So that sort of activity is something you could pick up. The one limitation of this is you obviously have to do it in advance. You can't get tweets that have already been published. You can't now set this up and say, go back to last year and what were people tweeting about. You have to start it going and then it will record tweets or updates that match a particular criteria from that point on. If you're in If This Then That, to start creating a scraper or creating a recipe, then you click on your name in the upper right corner and select Create Recipe. And you'll get the phrase, if this then that. So you get this line, you click on the big blue this, and you are asked to choose a trigger channel. And there's lots of options there, but if you start typing Twitter, Twitter will appear. Click on Twitter, authenticate it, and then move on to the next step. And the next step is to be a bit more specific. So Twitter is the trigger, but what is it that you want to activate this? It could be a new tweet by you. It could be a new mention of you or a link by you. In this case, if we were following an individual, we would specify new tweet by a specific user. If we were following a hashtag or a search, you could use new tweet from search. Now you might notice it says here limited to 15 tweets per check, and that's really important. If you are using this to scrape tweets on a particular subject and it's high volume, it will only get a sample of it. It will only get 15 minutes every half hour or 15 tweets. So once you've clicked on Twitter and authenticated it, you'll be given this option. If you select new tweet from search, you can follow a hashtag, something like that. If you select that, you can get everything by a particular individual. This one is anyone in an area. So if you were interested in a particular location, then you could set that up, bearing in mind that only about 1% of tweets are geo-located. So then you'll be given step 3, you'll be given the option. If it's an individual, it will say username to watch. Otherwise, it will be search, and you type in hashtag CIJ Summer or the name of the individual. I don't think you need to put the @ sign on actually, but it doesn't really matter. It will still work either side, either way. And then click Create Trigger. The next step is then that. When you click on that, you get the same box to search for your action channel, and this time you're searching for Google Drive. Again, you then need to choose a specific action, and the one that we want is add row to spreadsheet. It doesn't matter that the spreadsheet doesn't exist yet, it will create it when it finds the first match. While you're doing that, I'll point out some of these others because they're quite useful as well. Upload file from URL will actually go to a URL, grab that document, whether it's a HTML web page or a PDF or whatever, and it will save a copy in your drive. So if you are following someone closely and they happen to tweet links to documents, things like that, it will create a copy even if they delete it later. Likewise, you could use it on yourself. So I did it for a period where any link I tweeted, a copy of that link, a copy of that web page would be saved in Drive, so I had like a personal archive. It will do it in Dropbox as well or other services. So you click Add Row to Spreadsheet, and then you can customize some of the settings. So it will name the spreadsheet something like that, but you can delete that and put your own name. It will specify what columns are going to be in this row. So it's going to have one column with the name of the person tweeting, another column will have the text of the tweet itself, the third column will have a link to the tweet, and the fourth column will have a timestamp when that tweet was created. And then finally you can specify where it goes in Drive. By default it will create a folder called IFTTT, and within that a folder called Twitter, but you might want it to go somewhere else. The only thing left is to click Create Recipe. There's a summary of it. So if there is a new tweet by this person, or in your case, a new tweet matching a particular search, then add a row to a spreadsheet. And it's generated a title for it. Once you've created it, you'll be taken to the recipe page, and you can run it straight away by clicking Check Now. If you want to turn it off, you can do that there. If you want to delete it, you can do that there as well. So here's the one that I prepared earlier. I created this recipe yesterday. We've got a column with the username, a column with the tweet, a URL for the tweet, and the timestamp. So that's about the easiest scraper you can probably create. If you were doing the save the file at that URL to a folder, then I would start thinking about how big those files are likely to be and how you're going to manage that. And I would start looking at Evernote and adding tags at the same time, because Evernote's tag management is quite good in terms of if you've got lots of documents. And actually Drive is quite good in terms of searching within documents as well. So it depends what your purpose is, but you might have to factor in kind of buying extra storage space, that sort of thing, if it's important. This is what you're looking for. It's for DEFRA latest measured levels of air pollution. And I want you to copy that URL. So what I need you to do now is go into Google Sheets. And I want you to create a new spreadsheet. In A2, type an equals sign. As soon as you type an equals sign in any spreadsheet software, you're asking the software to do something for you rather than just entering data. What we're going to do is something called import HTML. So if you start typing import and then open parenthesis. Import HTML is what's called a function. And sum, average, median, count, those are all functions as well. Any word that's not in quotation marks is a function. And a function is a shortcut for a recipe. So as soon as you open a bracket, it tells you what the ingredients are, gives you an example, and tries to explain it. So import HTML will go to a web page, grab a table or a list, and bring it back. To do that, it needs 3 ingredients. It needs to know the URL of the page you're scraping from, whether you want a table or a list, which is known as the query, and which table or list you want. The first, the second, the third, whatever. And that's called an index. The first thing you need is a URL, and this needs to be in quotation marks. So open quotation marks, paste the URL, and then close the quotation marks. Then you add a comma, because we're moving on to the second ingredient. And the second part can only be one of 2 things, either the word table in quotation marks or the word list in quotation marks. And I happen to know that the data on this page is in a table, so open quotation marks, type the word table, close quotation marks. Final ingredient then, which table do we want? Now we don't know yet, so put a number 1 and then close your brackets and you'll get 1, 2, 3. And this is the table that it's grabbing. Yeah? Now, how do we know which table this is, if this is what we wanted? If we wanted to grab the data on levels of air pollution in central Scotland, for example, how do we know which table that is? Well, there's 2 ways of finding out. We can look in the raw HTML and count how many table tags there are, but that's a pain in the arse. It's much easier just to keep changing this number. So try number 3. So double click on your formula and then change the number from 1 to 3. Okay, so we're getting 789 now, which is this one. So we can guess that this is number 2 and that's number 4. And basically trial and error is generally going to be quicker than trying to go into the HTML and counting table tags. So I'll change it to 5. And there we go. You've now written 2 scrapers in the space of about 30 minutes. So that is grabbing it live, which has the advantage that if you check it tomorrow, you won't have to update it. It will have tomorrow's levels. But the disadvantage of you've lost yesterday's. Yeah. So one of the things with this is if you are going to use Google Sheets and you are monitoring something which updates regularly, you might want to copy and paste it as values only every day. And the way you copy and paste as values only is you select everything on the page, so press Control and A or Command and A on a Mac, or go to Edit, Select All. Then copy it, Command and C, Control and C. And then on a new sheet, and this is the key bit, go to Edit, Paste Special, Paste Values Only. With more advanced scrapers, if you're doing programming, or indeed import.io might do this, then you can run it every day and keep the previous results without having to manually copy it. So if you paste values only, what that's doing is not pasting the formula that you've just written and the results, but it's pasting just the results. So if you look on any individual cell, it's got the actual text, whereas if I go back to my scraper and click on this one, I've got the formula. So this one that I've pasted, I might call snapshot July 15 or whatever day it is. And this one might be my live scraper. You can also have automated charts. So you might have a chart for this, which is embedded on your site, and it's just pulling live data. You might have calculations which say, is this above or below a certain amount, or divide this number by that number. So it's a good example is election results. If you know what those results are going to look like, you can have all the calculations set up to tell you who's won and how many people have won from which party. You can have maps automatically drawn. One of the actions in IFTTT is send me an email. So you could say, if something happens on this spreadsheet, then send me an email. Also, these Google Sheets have essentially RSS feeds, so you could use that as a trigger. I'll show you another example. If you Google Numbeo pollution in the United Kingdom, you'll get a page like this. And if you scroll down on that page, you'll notice links to London, Manchester, Birmingham and Edinburgh. And just click on one of those. So I'm going to click on London. So this is where we're looking now at scraping multiple URLs. And if you look at the URL, you can see London is at the end of the URL. So it goes numbeo.com/pollution/cityresult.jsp ? Country equals United plus Kingdom and city equals London. What might I try now to test if that is useful?
Typing in the other name of Manchester.
Yeah, so if I type Manchester now instead of London, lo and behold, it works for that. So what I know from that is that if I have a list of cities, I just need to add the name of the city to the end of the URL to get myself a list of URLs. So there we go. So that's what's happening here. So I've got my London, my Birmingham and my Manchester, and I've got equals, open quotes, main part of URL up until city equals, and then close quotes, then ampersand, cell reference, where my city name is. So I don't need to go to each web page and copy and paste the URL. If I can see a pattern, if I can see a structure, I just need to find a list of cities or type a list of cities and then generate the URLs that I want to scrape. And then instead of typing the URL in the formula, you can put the cell reference containing the URL. In this case, it's the fourth table at that URL. But again, I can put a cell reference instead and put the number in that cell. But that isn't in quotation marks anymore. That's important. It's in quotation marks if you put it in the formula, but if it's in a cell, then you don't put quotation marks around it. Does that make sense then in terms of we've got a list of cities, from that we can generate a list of URLs, from that we can generate a bunch of scrapers. So the formula is pretty much the same, but it's looking at a cell instead of having the URL directly in it. But we've got a bit of a problem here because the table that we're grabbing is 3 rows deep and 2 columns wide. And that means that we've got these big gaps between each city. But there's a solution to this, and this is where your Excel experience comes in very useful, because you need to nest a formula now. The function that I'm using here is called index. Index is a function that will go to a particular table and grab a row and column that you specify. Index has 3 ingredients as well. So ingredient 1 is the table itself, ingredient 2 is the row number, and ingredient 3 is the column number. So we know that pollution index is in the second row and the second column. If that was what we wanted, then our formula has at the end of it 2, 2, row 2, column 2. The most complex bit of this formula is the fact that we've put import HTML blah 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 right in the middle of that as the first ingredient. If you've ever worked with nested formulas where you've got one thing happening within another, then you should be familiar with that. So you read it from the inside out. What that formula is saying is use import HTML to go to the URL there, grab a table at the number there, then use that with the index function to grab the second row and the second column. So with that, we only have one number, and it's doing that for all 3 cities. And obviously, you could do this down a whole list. We did this with property prices, and we had 700 rows, 700 place names, grabbing the average price of a 2-bedroom house for each one. And if you want to just check that the label is the same, then you can add another formula which just grabs, so this one's grabbing the second row but the first column, so that's the label for each of ours. So you're saying, yes, that is definitely the pollution index that I'm grabbing there. If I return to this example, this is grabbing from another web page. What we've got here is the function. A function has ingredients which are called arguments, also called parameters depending on the context. Each one separated by a comma. And these elements carry through into programming as well. If you start writing scrapers using programming languages, you use functions that will scrape and do other things. All those functions have arguments. They all have, skip past that. Anything in quotation marks is called a string, so it's a string of characters. This is an index, a position. Again, that's often used in scrapers as well. You want to go to a particular position in a list or something, or a range. And you will often get documentation that explains how the function works. So like that little box that appears in Google Drive, if you start to get into programming, you look for documentation to do with those functions. The other concept that I've tried to introduce there is using cell references. What you're essentially doing there is creating a variable. It's an object to hold something. And again, that's often used in programming because we want to change that. We might want to go to a lot of different URLs, and we don't want to have to rewrite the whole thing each time. So we could do it like that, for example, and it's much easier to have a scraper like that where you just have to change that cell or that cell or that cell and see the result rather than having to go into the formula and pick through to the second part or whatever. So there's a whole bunch of jargon there which in just 1 hour hopefully has kind of given you some tools if you wanted to do more advanced scrapers. But even if you don't, you can communicate with developers. You can hopefully start to understand a little bit the language involved in the advanced stuff. But even if you're not doing that, you've got a whole bunch of tools that you can use that are kind of click, copy and paste, IFTTT, Google Drive, Outwit Hub, import.io. There's also these functions which will do more, do different types of scraping. So if your data isn't in a table, import XML will go and find the particular tag that your data is within. All of this, by the way, is in the first chapter of Scraping for Journalists. So if you do want to explore this more, the book kind of takes you through import HTML, import XML, Outwit Hub. It takes you through some other techniques like regex, and then moves on in the later chapters on some really advanced kind of scraping challenges. So that's it from me. Thank you very much.